Hello, welcome once again to my channel. Today I want us to look at the block diagram simplification or reduction. For us to simplify a block diagram, we have several rules that we should master so that we can now reduce or simplify a block diagram. So today I want us to look at these rules, and the first rule is combining a series blocks or cascade blocks. Sometimes you find that in a block diagram you are given something like this one here. I have R1 as the input. I have this block G1. I have block G2, and of course, yeah, it should have the output C. So in this case, how do we get how do we simplify these two blocks which are in series or the cascade? So just multiply the two blocks. So this one should be equivalent to, so I have this block here like this. So I represent this one with G1 times G2. I'll have my input R1, then I'll have my output C. So that's how we simplify a series blocks. We just multiply them. That's what we have. Then we have rule number 2 is now combining parallel blocks. How do you know that two blocks are in parallel with each other? So the first thing, you find that if I have this block here, it is coming towards this summing point. I have this other block here, G2, coming towards the same summing point. So you've noticed that if I have these two arrows coming towards this summing point, then it means that the two blocks are in parallel with each other. So in a complicated block diagram, we can now combine these two blocks by adding them. So the term here is adding the two blocks so that the whole thing will be equivalent to, I'll just have to present them in one block like this. So I have this one is plus, meaning that G1 is positive, and this one is minus, meaning that this G2 is a minus. So we'll have here G1 minus G2 inside that block. Then I have my arrow. This is my output C. Then this is my input R. That's how we simplify parallel blocks. We just add them, then we represent them in one block. But for series ones, we just multiply them. We just multiply the blocks. So you have to get that difference. For series blocks, you multiply them. For parallel blocks, you add them. That's what we have. Then we have rule number 3. We can shift or move a summing point ahead of gain block. So for instance, if I'm given something that looks like this, I have x1 as the input here, I have x2 as the input here, then I have this block, then I have x3. Then considering this diagram here, you find that this x1, x2, then times the block are the inputs, then x3 is the output. So this x3 will be equals to, I have x1, which is positive, then minus x2, which is now minus. Then because the two of them are in series with this block, I'll just multiply by g. So that if I open the bracket, then output x3 becomes gx1 minus gx2. That's what we have. So if I'm reducing this block diagram, I can always shift this summing point, then I bring it ahead of this block. So this one should be equivalent to, I just I just have to put a block here. I just put a block here, then I put my G here. Just have another block. I put my block there. Then I put my summing point somewhere here, like that. Like that. Remember, this is now my x1, which was positive. This is now my x2, which was minus, like that. That's what we have. So we have my output here, which was x3. So we can always represent the whole of this one just like this one. We just shift this summing point here, then we bring it ahead of the block. So you have to recall that when we shift any summing point ahead of the gain block, then I need to create another block here. Remember, I had only one block, so I need to connect x1 with a block and x2 to a block. Then I take all of them towards this summing point. So for us to get the same x3 as the output, so this x3 will be equals to, these two are in series, so I have g times x1 is gx1. Then I have a minus x2 times g, which is minus gx2, like that. Then this becomes our output. Then you find that considering the two of them, then the outputs are just the same. The outputs are just the same. That is now our rule number 3. Then let us look at our rule number 4 is shifting a pick-off point beyond a gain block. So in this case, this is now, this one here is our pick-off point. These are pick-off point. So I can actually shift this pick-off point, then I bring it beyond or ahead of a gain block. So if I do that, then you find that I'll have something like this one. So this one will be equivalent to having, this is the x1. I connect this x1 to the gain block like that. But now, what you should note, if I take this point from this position to be beyond a gain block, then I'll have another block here. I'll have another block here, which is now the reciprocal of what I have in this block. So in this block, I have g. The reciprocal will be equals to 1 over g. Then I'll connect this one to x2 like that. Then I have, then I have something like this. This is now my output. That is what we have. So you will always create another block here, and what you have inside that block is the reciprocal of what we have in this block. So in this block I had g. If I take this point beyond this block, I'll have 1 over g inside this block. I connect it to x2, then this one is x1, then I'll have the output c. That's what we have. That is our rule number 4. Let us look at our rule number 5. Rule number 5, we have interchanging of summing points. So it doesn't matter how you place or the order in which you place your summing points, the output must be just the same. So for this case, I'm given x1, which is positive. Then I have my summing point. I have x2 from the other side. Then the two of them are coming towards this summing point. Then we have minus x3 in this summing point. Then we have our output x4. So how do we get this output x4? This x4 is equals to, we have positive x1, so I have x1 plus, this is x2, like that. Then plus minus x3, we'll have minus x3. That is our output for this case. So if I'm simplifying my block diagram, and then I find that I have something like this, I can represent this one with just a simple diagram that has a summing point like that. Then I can have this one as my x1. Then I can have this one as my x2. This is positive, this is positive. Then I have this one as my x3, which is minus, and then I have x4. That's what we have. So in the same case, for us to get this output x4, we will have our x4 as this is x1, which is positive, plus x2, which is also positive. Then we will have minus x3, because you can see that x3 is minus, so we'll subtract. So you still find that the answers for the two are just the same. So in a case where we have a block diagram that has several summing points, you can just interchange them, or you can just replace them with just a single summing point, and then that will not affect the output like that. So now let us look at rule number 6. We can split or combine summing points. We can split summing points. So in this case, I'm given a summing point like this. It has x1, that is minus x1. It has x2, and it has x3. Then we have the output. So in this case, the output C will be equals to, the output C will be equals to minus x1 plus x2 plus x3, because you can see that these two are positive but x1 is minus. That becomes our output. So we can represent this one as the like this one, so that here we have this is, I can draw a summing point here like this. This was plus, this was plus. I can just put my x2 here. Then I can just put my x3 here. Then I can have this summing point like this. This was minus. I connect this one to minus x1. We have that. Then I have the output C. So if you want to get the output C, then I'll have C is equals to x2 is positive, so x2 plus x3 is positive. When it comes to this summing point, I'll have minus x1, which is negative. We have that. So you still find that the output for the two of them is just the same. So you can split this summing point to be like this, or you can combine this diagram to be like this. So it's just the same as having something like that. That's what we have. Then let us look at the rule number 7. Is replacing or eliminating any closed loop system by an equivalent open loop system. So I'm given this kind of a block diagram. It has input R, just a summing point. It has only one block in the forward path. I have the output. Then I have the feedback element, which is block H, then something like this. So kindly ignore this line. Ignore this line, it was not there. It was just a mistake. So we have something like that. And then this one is like our canonical diagram. It has only one block in the forward path. In this case, this is my forward path. Then it has only one block in the feedback path, and all this that is fed back to the input is our feedback path. That's what we have. Then for us to replace this one with an equivalent open loop system, we need to calculate for something we call the control ratio C over R. We need to calculate the control ratio, and this control ratio is always G, which is our forward block, over 1 plus or minus G times the feedback element. We have that. This is our control ratio C over R. So for me to replace this closed loop system with an open loop system, I need to get C over R, that is the control ratio, by having, this is G over 1 plus or minus GH, like that. So that if I plot it, it will be equivalent to, just plot one block like this. Then I put my values, G over 1 plus or minus GH. Then I will have my input, which was R, then my output, which was C. That's what we have. So when we are simplifying a very complicated block diagram where you find a closed loop system, you can always replace it by with an open loop system by calculating the control ratio, what we've done here. And this one, you just plot it in one block like this, just indicate your input, then your output. Now this is our open loop system, which does not have any feedback. That's what we have. Then the last rule we have, shifting a branch point before the block. So I'm given an input R. I have a block here. Then if I remember, the two of them are in series. So for me to combine the two of them in series, I just take R times G, which is RG, like that. Then I have this branching point here. So the output for this one is still R times G, which is RG. So if I want to shift this point to, then I bring it before a block, then I'll have something like this. I'll just have R here, then I'll just put a block here, then I put this point before the gain block. But remember, each one of them has a gain block, so I just indicate my G here like that. Then I'll have the output for this, then the output for this. Remember, if I consider this one, this path here, R and G are in series, so I combine them by having R, G. Then if I consider the other path here, the two of them are in series, so I'll have R, G like that. So you still notice that the output for the two is just the same. And those are the rules that we use to simplify complicated block diagrams. Thank you for watching, and please, if you are new, subscribe to my channel. And I'm posting another video having an examples on how we apply these rules. Thank you.